Hey Massimo. Hey man,
I
how's it going?
I fine, fine. It's a pleasure for me to be here.
It's a
Thank
pleasure
you.
to have you here. So yeah, um, before starting, let me just briefly introduce you. I know you will introduce yourself a little bit more, but guys, like I said, Massimo Bonanni, empower every Azure function to achieve more. This is the name of the session. For your information, Massimo is Azure technical trainer at Microsoft. This is what coming from my notes. And Massimo, correct me if I'm wrong, but you spend most of your time helping customers and partners to empower AWR, Azure
No problem.
skills, yeah, to
No
achieve
problem.
more and leverage more power from coming from Azure. Yeah, my mistake. No
No problem.
AWS in that.
No problem. No problem. Yeah, I am a technical trainer, so my job is to explain to the customer and to the partners the Azure technologies. So yeah,
So the floor is yours.
thank you very much. Okay, let's restart. My name is Massimo, as Carol introduced me, and I want to talk about one characteristic of Azure Function. Azure Function has the capability to extend the feature you can have, the way you can interact with external service. But before we start to go deeply in the topic, I want to explain what are Azure Function, because I want to give you a basic about that. Azure Function are a serverless technology in Azure that allow you to react uh, uh, to events generated by a search. For example, if you want to react when someone write a blob in a storage, you have an event, the blob storage, the blob created in a storage, or I don't know, an HTTP call, or a message in a queue. Then these events run your function. Your function is literally a snippet of code written in C Sharp, F Sharp, Node.js, Java, Python, and PowerShell. And the purple arrow in this slide is called trigger. The trigger is the way the platform, the runtime of the Azure function, fires your piece of code, your snippet of code, when something happened in a source. But you need to interact with external service. Probably you receive an HTTP call. You need to, I don't know, send a mail or do something similar. In the Azure platform, in the Azure Function platform, you have another arrow. This is another component called binding. The binding, you can have more than one binding, depends on the scenario, and the binding allow you to interact with external service. So, for example, when someone create a blob in a blob storage, you run your function and write something in the Cosmos DB, and I don't know, send a notification using Notification Hub. What is the problem? This is an example. The trigger fires your function. You receive a payload from the trigger. Using the binding, you can retrieve data and write data. Of course, the bindings can be bidirectional. You can write or read data. It's not, depends on the platform you want to use, depends on the services you want to use. And your code can manage the payload returned by the trigger and returned by the each binding you want to use. So the idea is, this is a simple example of function. You define what kind of trigger you want to use. In this scenario, you have a queue trigger, so you react when in the queue called my queue item source, someone put a message, yes, exactly, and you receive the message as a JSON string. But you can use also trigger. In this scenario, you have a queue trigger. So you want to take a message from a queue and write in another queue. It's just a simple example, but you can imagine that you can have one trigger as you want and one or more bindings in your function. And of course, the bindings has its own payload. What is the problem, the issue? The issue is you have more or less 20 types of triggers and binding. So, for example, you cannot fire your function when someone write a row in a database, in a SQL database, because you don't have a trigger for that. And also, for example, you cannot send a mail using Office 365 or Google, Gmail, I don't know, because you don't have a binding for that. But fortunately, the SDK, the Azure Function SDK, is based on another SDK called the Azure Web Jobs SDK. And this one, Azure Web Jobs SDK, is extensible. So you can extend your trigger or your binding, and you can write your own triggers and bindings. It's not the rocket science writing your own triggers. It's just important to understand what is the phase then a single function throw between the starts and the moment when the trigger starts the function. So for these reasons, I want to emphasize these phases. You have two principal phases in the life cycle of an Azure function. The startup phase. In the startup phase, the runtime try to register the built-in binding, for example, the timer trigger and the HTTP trigger. And you, in this phase, I show you in a demo later in this session, you in this phase of the life cycle can register your own extension, your own triggers and bindings, depending on what you want to do. Then the function, the runtime of the function go in running mode, in running phase, and in the runtime phase, every time a trigger fires for a function, the runtime try to run the piece of code, your function, and yeah, it's completely different because the startup happen one time when the hosting starts. The runtime happened every time a trigger tried to run a function. So what's happening in the startup phase? First of all, the runtime register its own extension, its own trigger and binding, and you can register your own triggers and bindings. Then the runtime look at your code and try to discover all the functions you define. You define a function using an attribute that say to the runtime, hey, this is a function, and I want to host in the runtime. After that, when the runtime discover a function, a method that you want to run as a function, the runtime try to resolves all the dependency you put in the function. So try to create all the triggers and all the bindings you put, because if you don't have the right packages or your classes you create for creative trigger and bindings throw an exception, that particular function will be removed from the list of the function you have in the runtime. So the runtime starts again, but your function is not available because the runtime cannot resolve all the dependency you put in the function. Then for each function that it's okay for the point number 3, for the step number 3, the runtime create an internal representation. This is because when the function runtime needs in the future to start your function, to run your function because a trigger fires it has immediately the internal representation. It's exactly know how the function is composed, what are the trigger, what are the bindings, and so on, and then can run immediately the function with the low latency in this way. Then finally, for each trigger, the runtime find in the number two and create in number 3. For each trigger, start a listener. The listener is the more important classes I show you in the demo, because the listener is the way the runtime look at, listen to the source and run your function. Of course, you can understand that if you create your trigger, you need to create your listener. And depends on the platform you want to interact with. Your listener may be a polling listener or and publish and subscribe listener. I show you a demo in a while. In the runtime phase, what's happened? Yeah, every time a trigger run your function, every time a trigger try to run your function, The runtime retrieving the function definition created in the startup phase, and then use what is called binding object. The binding objects are classes that allow the framework to create the payload you receive from the trigger and from the binding. And finally, and it can do it because it check in the runtime phase, so it has the classes and so on, and then run your function. So the phases are completely different, and when you create your trigger and your binding, you need to know which phase your classes will be used. For example, when you create the trigger, you create 4 classes. As you can see in the upper part of this slide, you have these 4 classes. I show you later what is the responsibility for each of these. But finally, the first one, trigger config provider, the provider is the way you extend the function. Inside the config provider, you can have more than one trigger and more than one binding. Imagine you create a set of triggers and a set of bindings that you want to distribute them to all of your developer teams. You create one config provider, then when the people want to use your bindings and triggers, need to use this config provider to extend their function. So in the first step, the platform use this config provider to create for each trigger you define a binding, a trigger binding provider. This is the factory. This is the factory that the platform used to create the class, the trigger binding. This is the factory the platform used to create the trigger binding, and this is the way you can check the configuration. You can check if the parameter you receive in the definition inside each function are right or not. And then you can throw exception and so on. The trigger binding, so the next one, in the trigger binding, the trigger binding is the class that are responsible for the creation of the listener. And finally, and this chain happened during the startup phase. And finally, the platform use the listener generated through the trigger binding and start it. In this moment, the listener start to listen to the source, look at the source, and when he find that something happened, start your function. What's happened? This is your classes. You need to create at least these 4 classes. Actually, you can create more than this one if you want to implement something special, but this is not the purpose of this session. I just want you to give you an idea of how it's difficult and how you can proceed to extend your function. During the binding lifecycle, the binding lifecycle is different because it as a part during the startup phase. During the startup phase, the platform use a binding converter, a class that you need to create. This one, you already have the binding, the config provider, as I mentioned you before. Here you can have binding and triggers, as I said you. But during the startup phase, when the function try to resolve the dependency, use this part, this class here, binding converter, to create to try to create the binding converter, because this is the way you can create during the runtime phase the payload you receive inside the function. So the binding is easiest than the trigger, but in any way you need to create at least 3 classes. Okay, one for the provider, the extension, maybe the same that you created for the trigger. It's not you don't need to create one for each binding and one for each trigger. You can have one that extend your function with several triggers and several bindings, and 2 for binding converter, the way the runtime create the payload that you receive during the run, and the binding instance. The binding instance is the the payload, maybe an interface that allow you to write in a storage or read from the database, maybe a payload just contain data, and so on. Okay. Let me show you a demo. Okay, I have. Okay. First of all, I create this. You can find this demo in my GitHub. Actually, I have two demos. One for SQL. I create a trigger and binding for SQL. I show you. I said you that we don't have a Microsoft trigger for SQL, so maybe an idea to look at my projects to understand how it works. And this one, in this sample, I create a trigger that look at AccuWeather. AccuWeather is an external service, third-party service that allow you to retrieve the temperature for a city or the weather for a zone, for a region. In this scenario, I use the endpoint that allow you to retrieve the data for a single city, and I create a trigger. I call it weather trigger that received the city. In this sample, I use Varsavia. The threshold for the temperature. So the trigger look at the temperature. When the temperature change between one polling and the other for more than this value, fire the function. It's just an example, but you can understand how you can integrate an external service. And here is a configuration that tell to the trigger check every 15 seconds. Of course, you can add here your parameter. Depends on what you want to test, want to interact with the external service. This is the payload. What is this payload? This contains the name of the city, the current temperature, the time I take the temperature, and so on. So when the trigger fires your function, you receive all the data that generate the trigger. Okay. Look at how I create this trigger, just to give an idea. First of all, startup phase. This is the startup phase of our host for the function. I create an extension method. This method I look at this method and just use this weather trigger config provider. This is the class that contains all the definition for my triggers and my bindings. In this sample, only one trigger. And I say, hey builder, hey web job builder, hey runtime, take this config provider and register all the new trigger I give you inside this config provider. I want to show you what's happened inside this class. You have initialize. In the initialize method, you define what we call a binding rule. This is this binding rule say to the platform, hey platform, this is the attribute the developer can use to declare that he wants to use weather trigger. So when you find this one, you need to use this payload, and this is the class you can use to create all the chain we saw in the slides. In this binding provider, this is the factory that allow you to create the binding class and then the listener. You check the configuration. So for example, I take the attribute key because I use an external service. So probably in the configuration, not in the definition of each function, but in the file, in the configuration file, I have the API key to interact with the weather services. Because when you create an account in AccuWeather, AccuWeather gives you a couple of keys you can need to use to interact with him. Then get the attribute second. So the second I put in the attribute, but for example, I need to check that it is more than 0 and less than, I don't know, 1 million. Okay, I need to check. So here is the place when you can check the configuration, check the value in the attribute, and so on. Then if it's all okay, I create the new trigger binding. This is the class that the platform use in runtime in startup phase to create to memorize, to store the definition of the function, and using in the startup phase to create the listener. Here, I create the listener. I call it the weather trigger. It's easy. I call all the classes weather trigger because it's related to weather trigger, and then I put listener, binding, and so on. This is the core of the trigger. In this class, I have a method called start async. I need to manage all the methods, of course, but it's important to. I want to show you the start async. In this start async, I start the listener itself, and the listener what does. Simply make a while, okay, and every seconds you set in the attribute. Call an external service. This is the call to AccuWeather to retrieve the data. And if the temperature I retrieve now is more than the previous temperature, based on the threshold you put in the configuration, I create the payload and use an executor. Executor is a component of the runtime, of the Azure runtime, the Azure Function runtime. Try to execute. So when I understand that I need to fire the function, I run this command, this method, and my function starts. I want to run it. The first time the listener start because he hasn't the previous temperature fire the first time the function, so I will have a break here and then a break in the function. Let me check here. Okay, then we can leave the function running, and I want to show you the binding part of the demo. Wait for the start. Let me drink something. I'm running the function locally because Azure Function is based on Azure Function runtime. The Azure Function runtime is a runtime you can run on your machine. You can run inside the container, or you can run, I don't know, in a Raspberry Pi and so on. So this is the way I can debug my function locally. Okay, now it's starting. I remove all the log, so I put the log at minimum. But if you put the log at maximum, so you can say exactly all the phase in the startup phase I mentioned during the slide. I want to show only my log, only log of my classes. I don't want to have the log of all the Azure Function runtime because I don't want to have a lot of things in the screen. But if you configure the log to write everything, you can see exactly each step in the phase. Okay, as you can see here you can have a starting listener. Why I put this code in weather trigger listener? Because for every function you have an instance of the listener. So if you define 3 functions weather trigger, one for Warsaw, one for Milan, and one for Rome, you have 3 listeners that look at because every listener can be different setting. I don't know. In Milan, I want to check every 30 seconds. In Rome, I would like to check every 3 minutes. Okay, so because the configuration is on listener, you have 3 different listeners. So if I run, I don't know, 3 function with the same trigger, I see 3 different code, 3 different string near the weather trigger listener. But the listener is starting, gets it info, so the listener retrieve the data from the external service, and here create the payload. Let me go. Okay, create the payload. As you can see, the payload is a simple class that contains the name of the city, the temperature, the timestamp of the temperature, and the last. So I can have I can manage these events inside the function, and then this is my function. Okay, and here I just write a message, but you can understand, you can do a lot of things. If I continue to run this one, the yellow row is the row written by the function. Every 15 seconds, I see another get CT info async. Yeah, because the listener start to continue to work. So continue to listen to the external service and so on. Okay, I leave the demo here because if in the meantime the temperature will change, we have another function. Okay, and I want to close because it's near to the end. Just to recap a couple of things. Okay, a couple of things. When you implement your trigger and bindings, you implement a sort of dependency injection. So you give to the platform the responsibility to create the class. So it's a way to abstract your code from the source. Okay. Pay attention because in the function you pay for duration and occupation of the memory. So write the class in the right way. And finally, most important, I tell you before, the listener is important because the listener is one for each function. You pay for the memory. The listener is important for scalability and performance. So write once and the best you can. Thank you very much for your attention. I will respond. I will answer to your question in the chat. So I will remain connected. Join. It's okay. Bye.
Thank you, Massimo. Thank you for your time, for preparation of your presentation, and giving us some value coming from Azure, because we are talking
I hope so.
about
I
this.
hope so.
Yeah, it was a great value. It's the community about the serverless, so it doesn't mean whether it's coming from either Google, Microsoft, AWS, or whatever. So
I agree
once
with you.
again, I'm really grateful to have you here. Please stay with us on the chat. So guys, if you have any questions, feel free to ask. And I would have almost forgotten regarding Goiko. Guys, if you have any questions, send me a DM. I will forward that question to Goiko and get back to you with the response. So once again, sorry for him for not be able to be with us today. But if you got any questions, feel free to ask. Massimo, once again, thank you very much.
Bye, guys.
Take care.
Take care.